Hello everyone, in this video we are just going to interface OLED display with our ESP8266 by developing respective Python scripts using Tony IDE. Let's get started. So before getting into the Python scripts, let's discuss in detail about the layout schematic that we are going to build for interfacing SSD1306 OLED display with our ESP8266 or with Node MCU. So as we discussed, we are just going to discuss about the schematic diagram that we are going to build for interfacing OLED display with our ESP8266 Node MCU module. So on the left you can see the Node MCU or ESP8266 module, and on the right you can see the OLED display module. So this OLED display module is also available in an SPI communication format, and the one which we are going to interface is of I2C communication, that is Inter-Integrated Circuits Protocol. So I have explained in detail about this particular I2C protocol in a separate video. The link for that video is available below this video, and also you can find that video in the same playlist of this particular video before this particular video. So I hope that will also help you. If you want to learn in detail about the I2C communication, just watch that video before watching this, or if you are not interested in that, you can follow this particular video. So now let's discuss in detail about the connections that we are going to make in breadboard for communicating this particular display with our ESP8266. So you can clearly see I2C protocol has only two lines required for communicating. One is clock and one is data. So SCL right over here is clock and SDA right over here is data line. And other two pins that are available in our OLED displays, VCC and ground, which are helpful for powering up this particular OLED display. So this VCC I am just going to power up with the help of the power from the Node MCU. I will be connecting the Node MCU to PC through micro USB cable, and the power for that particular Node MCU will be provided by the USB port of my PC. So I will be taking the same VIN power and I will be providing it to the OLED display. And ground, I am just going to connect the ground of the Node MCU to ground of OLED display. So I have powered up the OLED from the Node MCU itself. And clock pin, I am just going to connect it to D1 of the Node MCU right over here. So I am just taking D1 for connecting the clock pin of OLED display, and data pin I will be using D2 pin of Node MCU. So I will be connecting the SDA line of OLED to data pin. That's it. So this is the connections that we are going to do. We are going to power up the OLED display with the help of same power from the Node MCU, and a clock pin will be connected to D1 of Node MCU, and data pin will be connected to D2 of Node MCU. So this D2 is nothing but GPIO4 in the script, and this D1 is nothing but GPIO5 as per the internal naming of the GPIO pin. So we will be using this particular internal naming 4 and 5 in our Python script for configuring the I2C protocol, but external naming for this particular GPIO 4 and 5 is D2 and D1. So externally we will be making this connection as D1, D2, and internally in our program we will be using the namings as GPIO 4, number 4 and number 5 for D2 and D1. So this is the schematic that we are going to build, and let's write down our Python scripts for writing some text onto our OLED display with the help of Node MCU by building this particular schematic diagram. So only 4 connections will be made: VCC, ground, SCL and SDA in the breadboard. So I hope you just got to know in detail about the layout schematic that we are going to build for interfacing SSD1306 OLED display with ESP8266 module. And now let us try to build our Python script for interfacing OLED display with our ESP8266. So this is the Tony IDE which we are going to use for developing our Python script. Just click on this particular icon or click on Ctrl+N on your keyboard for creating the new Python file. And I am going to save this by clicking on Ctrl+S. This computer, and move to the folder where you want the Python scripts to be saved, and I'm just creating a new folder right over here. I'm going to save it as SSD1306. And when you save this particular file, you can clearly see it automatically saves in the format of .py, that is the Python file format. So automatically it takes the Python file format for saving the files that you are saving right over here in the Tony IDE. So here I just want to import two different things. One is from mission, I'm just going to import pin for using the GPIO pins of the ESP8266, and from mission I'm just going to import I2C. So as we discussed in detail about the connection between the ESP8266 and OLED, we are just going to use the I2C protocol, that is integrated circuits or inter-integrated communications for communicating with the OLED. So we are just importing the I2C library for OLED display, and further we are just going to import SSD1306. This is the library for interfacing and using the APIs required for SSD1306 OLED display. And as the initial step, we just discussed that we are just going to connect digital pin, external digital pin D1 to the SCL of display. So which means D1 is nothing but GPIO5, and further D2 external pin will be connected to SDA pin, which is nothing but GPIO4. So this is the connection that we made, and you can clearly see from this particular diagram, D1 is GPIO5 and D2 external connector pin number is GPIO4. So this is what I have mentioned right over here. D1 is GPIO5 and D2 is GPIO4. And following that, I am just going to initialize my I2C communication protocol in my ESP8266. So I am just declaring a variable I2C is equal to capital I2C, which is a function call, and inside that I am just going to name the SDA pin to be pin 4. And following that, the second parameter of this function call should be SCL, obviously. So SCL pin will be GPIO5. Sorry. So this particular line will configure the SDA pin to be GPIO4 and SCL pin to be GPIO5 in the name of the variable I2C. And following that, I just want to initialize and configure the display, that is SSD1306. So I am just providing and defining a variable called display. I am going to give it as SSD1306 dot SSD1306 underscore I2C. And as I mentioned, this particular display is having 128 pixel horizontal pixels and 64 vertical pixels, and we are using I2C protocol for communicating. As I mentioned before, we also have a provision for interfacing the same display modules using SPI protocol. So now we are just going to use I2C in this particular library. So we have just passed that I2C as the parameter, that is this particular I2C which we configured to be SDA to be 4 and SCL pin to be 5. We are passing it right over here. If you are using SPI communication, you just want to configure for SPI communication right over here, and you want to pass the relevant parameter right over here. And that's it. That's all about the configuration and initialization that you want to do. And now let's move on to the API part. So I'm just giving it to be display dot fill of 0. So this particular display fill of 0 will actually empty the display initially, and following that let's learn to write some text on the display and visualize it in our hardware. So I have already built my schematic in my breadboard. As we discussed the schematic diagram, we have connected VCC to the VCC of OLED, ground to the ground of OLED, and SCL is connected to D1 and SD is connected to D2, and we have built the circuit in the breadboard, and we are just going to visualize some text that we are going to build via Python script right over here in our Tony IDE right now. So here I'm just going to use an API called text, and let me just name the text to be SM Academy, and following that I just want to provide the row number and column number. Following that I just want to provide the color in which I want to print. So color is nothing but we have a monochrome OLED display which has only one color. So if I provide 1 right over here as the parameter, I will get the monochrome color, that is in our case we will get blue color, and if I provide 0 it will be inverted, that is we will get a black color. That's it. So for setting the contrast or color we are just using this 4th parameter right over here. From the starting pixel of the display I am just going to display the text SM Academy. Following that, if you leave this code as it is, we will not get anything printed on the display, since we want to call a function called display.show. So this show function will update the buffer value so that we will get the text printed on our OLED display. I have just saved the script, and I have already connected my Node MCU to my PC through micro USB cable. I am just running the script. You can see my SM Academy has been printed on my OLED display in my breadboard circuit. So now let's try to make a function for printing the text onto our OLED display using the ESP8266. Till now we have been using this particular format for printing. We will be filling the buffer with 0 values, and we will be filling the text, and then we will be filling the buffer with the show function right over here. Let us try to build a function for doing all this process at a stretch. So def of OLED string, and we will get 3 parameters x, y, z and c. So inside this I'm just going to call these 3 things, and here in the first place I will be passing x, second place I will be passing y, third place I will be passing z, and fourth place I will be passing c as the parameter c. That's all about the function. So let's try to demonstrate this function that we have defined right over here. So I'm just calling this function with the text. Let's take it to be Micropython, followed by I will be printing this at 10th row pixel and 10th column pixel with the contrast of 1 in the blue. That is, I just want the Micropython to be printed at with the color of monochrome high color. Sorry, I forgot the colon right over here. I'm just saving the script and I am running this particular script with the help of this particular icon or Fi in my keyboard. You can clearly see the Micropython has been printed on the OLED at the respective positions where we have mentioned in the program, that is 10, row 10 and column 10, with the LEDs turned on state. So this is how you can build your own function for printing whatever you want on your OLED display with the help of SSD1306 library and I2C library from our mission library of Micropython using Tony IDE. And in the following upcoming videos we will be learning to display graphics on our OLED display using ESP8266, and also we will try to simulate some animations that you can print on your OLED display using ESP8266 in our future videos. I hope you learned something new in this video. See you in the next video. Thanks for watching.